audible? Good morning. Good morning, everyone. Thanks for being here early morning for an exciting hands-on workshop. And today we'll explore how you can run your generative AI models right on your on your laptops, not even a desktop, right? So you can run it right on your laptops, and break the myths that generative AI models can run only on GPUs. So before we proceed, there's standard notices and disclaimers. Since we'll be showing a lot of numbers and things like that, standard notice and disclaimers. And myself, I'm the AI software engineering manager at Intel. I handle the customer engineering from the Asia Pacific region. And as part of my role, I help all the customers in this region, right? All the enterprises in this region to optimize their AI solutions right from ideation to production. Right? And as part of that, we will do a lot of workshops, training, and have one-on-one collaboration with customers engineering team. So we'll have 3 agenda. We'll briefly introduce generative AI, and then we'll talk about Intel's hardware and software story with respect to AI, and then we'll get into the hands-on demo. So some prerequisites is, mostly if you are already aware of Python programming to a little bit extent, you should be able to successfully execute this workshop. I think everybody has access to an AI PC. We'll talk about what AI PC is, how is it different from the normal laptops. And most importantly, you should have eagerness to collaborate. This is a live workshop that is happening in a very crowded space, and all of you are connected to the same internet, so we might face some technical glitches. Don't worry, we have our experts spread across the room. They will help you out. The intention here is to learn and collaborate and try to bring that AI story to your enterprise. You can learn something from here and take it back home. And if you are implementing certain AI solutions at your enterprise, definitely we will help you to plan that and optimize it. So let's talk about generative AI. I think most of you are already aware of generative AI and have been using ChatGPT and other tools, and so I don't want to tell what is generative AI. But if you look at the history of generative AI, right? Generative AI, when most probably it became popular after ChatGPT, when it was released in 2020, right? Mid of 2020. It was released in mid of 2020. And then the ChatGPT 3 had 175 billion parameter model. It was the model that was released to the outside world, and we were all happy using it. It used to do a lot of our jobs, like writing emails, writing congratulatory messages, or even programming. You can ask it to write a code and it can generate a code for you, and you can ask any questions, and it will be, or maybe mathematical problems, it will be able to solve for this. And with the time, as time passed by, there was a hype, or there was a myth created that all these generative AI models can be run only on GPUs, because ChatGPT was running on GPUs. It was trained on a GPU. I think it used around 16,000 GPUs running more than for 6 months continuously to train that model. So that created a myth in the market that you should have a GPU if you want to work with generative AI, right? And that's to a certain extent. Initially it was true when you're dealing with all these huge models, right? 175 billion, and now ChatGPT 4, it is around 1 trillion parameter models. And now if you look at from an enterprise perspective, let's say you're working in a banking sector, you're working in automotive industry, or you're working in healthcare, or you're working in manufacturing. And when you look at ChatGPT has, or the 175 billion parameter model has data starting from, I think, 3500 BC. All the written records from 3500, publicly available written records from 3500 BC till of mid of 2020, whatever data is there. It's all there in that 175 billion parameter model. And for an enterprise who is dealing with healthcare, who is dealing with, say, specifically on manufacturing or automotive, they don't need all this data that is backing to 3500 BC, right? What we recommend is, use a smaller model. Use, like, say, Llama 3 billion parameter model that has general intelligence, and then take data that is very specific to your specific domain. Let's say you're working on healthcare. Let's say you're working on, say, gene therapy, right? So you can take all the data that is publicly available, data that is available with gene therapy, and then you can actually fine-tune the model. Fine-tuning is basically a process where you install more additional intelligence to the already existing model, right? You are embedding more data into the already existing model so that model becomes intelligent with respect to the specific domain that you are working on. Let's say you are working on automotive sector, right? And you might have all the publicly available data on related to the ECUs and the control sector, control units and things like that. And you might have some specific details about your specific domain, right? Like you might have IP related for your IP related to your company. So you can take this data and then actually can create a model that is specific to your particular domain. And that way, you can reduce the overall complexity of the model and then ensure it works flawlessly for your specific use case. It gives you more accurate information for your use case. And this is, we are talking only about the enterprise. If you have to build something related to consumer grade where it needs to know everything, even for the consumer grade, you can be specific. Let's say you are building a consumer grade generative AI application for healthcare, for education sector. Say you want to build something that knows how to solve a SAT exam or JEE exam or NEET exams. So you can take the course materials and then fine-tune that model with that so that the model becomes super intelligent on that particular course and can help students or teachers to solve those competitive exams, right? And other important thing is all this also requires a huge amount of computing power. Like I said, the 175 billion parameter model required almost 16,000 GPUs. And how many companies are able to offer that kind of hardware resource for developing their solutions, right? And just to give you from a memory perspective, how much memory is required. Here I'm taking a Llama 7 billion parameter model and quantized it to 16-bit. So quantization is a process where you actually compress the model, say from floating point 32 to floating point 16. So here I'm taking a Llama 7 billion parameter model and trying to estimate how much memory is required just to load the model. I'm not even executing the inferencing the model, fine-tuning, nothing. I'm just loading the model. And if you compute, right, just to load the parameters, you need almost 7 billion parameter into 2 bytes. It almost takes 14 GB of memory just to load the parameters. And then the key value cache, it requires additional around 1 gigabyte of memory. And totally, if you compute, it comes to around 67 GB of memory just to load the model, right? And now you might not only load only the model, you might be loading the Python compiler, you might be having the OS, you might have other database things and things like that in your application. And all that adds to the memory, total amount of memory required. So this gives you a picture. When you're dealing with generative AI, you need large amount of compute, large amount of hardware resources, specifically the memory, and things like that, right? With that thing in mind, you don't go with the market hype that you need to use a huge model. Go with a smaller model, fine-tune it. Fine-tuning a model to a specific domain gives you better results than using a bigger model. Let's say if you are using a 500 billion parameter model, yesterday I was talking to one of our participants here, and they were planning to use a 500 billion parameter model for a specific use case, and they were expecting good results. They were assuming that 500 billion parameter model will automatically give better results for their use case. But the reality is, it not necessarily it can give you that results that you are expecting, right? And on top of that, to run a inferencing of a 500 billion parameter model, you need a huge hardware. And that can actually eat up your profit margin, right? When you're deploying that application into production, the total cost of deployment will be huge that you might end up losing the profits. So what we recommend here is build models that are specific to your industry domain. Like you might be working in healthcare, education, finance, retail. Here are some of the use cases that are shown up here. Build models, take smaller models, fine-tune it, and then deploy it. Once you deploy it, a smaller model. Here on the laptops that you in front of you, it's all called AI PC. AI PC is a new generation of laptops that has a processor called Intel Core Ultra. How does Intel Core Ultra differs from Intel Core series of processor? Intel Core Ultra has 3 types of compute element. We'll discuss the details. I think yesterday over attended Sriram. How many of you attended Sriram and Anisha's session yesterday? Only few. I think majority have not attended. So I'll probably brush it up very quickly. So how AI PC differs from the traditional computers is the AI PC has a class of processor called Intel Core Ultra. The word Ultra is important here. What it signifies is the processor, that silicon that is used in those laptops has 3 different types of compute element. It has the traditional CPU cores, it has a GPU cores, it has a new class of compute element called NPU or Neural Processing Unit. We'll discuss about that in the future slides. So what I'm telling you here is, there are fine-tuning. I'm asking you to take up a smaller model and do the fine-tuning and build customized domain-specific models, right? And there are 2 ways to do that. You can do a fine-tuning or you can do a RAG. How many of you are aware of what is fine-tuning, RAG? I think majority of you are aware of. So I'll just briefly tell you, like fine-tuning, if you have large amount of historical data, use fine-tuning process, and it's a one-time process where you can add additional intelligence into the model. But if you have smaller chunks of real-time data, use RAG so that your model becomes aware of the real-time trends that are happening. Your model is not only aware of the historical trends, it also can be aware of the real-time trends, right? So if you have smaller chunks of real-time data, use RAG. And then there are 2 techniques you can use. One is you can use OpenAI's or Azure API services, paid services, and you can implement fine-tuning a RAG on that. Or you can use open source models like, say, Llama, Falcon, Bloom, Mistral, or any of those kind of models, and you can actually implement fine-tuning or RAG on that based on the use cases, and generate domain-specific model like a finance chatbot or a code generator. Code generator is something that is picking up a lot, right? You might want, as part of the demo, if we have time permits, I'll show you how we can actually have a code generator running right on your laptop. So to summarize these things, Intel has varied class of silicons that addresses varied needs, starting from AI PC that targets the consumer grade compute requirements. Like I said, AI PC can handle, the recommendation is it can, if you have 1 billion parameter models, you can run the inference, but we have tested even today, probably we might run an 8 billion parameter model or a 7 billion parameter model on the laptop and see how you can do the inferencing on your laptop itself without the need for any external internet connection, right? You're not connecting to any external source. You're running that 7 billion parameter model right on your laptop. And then if you have up to 20 billion parameter models, you can use the server grade Xeon processors. And if you have 100 billion parameter model, you can use multiple GPUs or multi-socket Xeons. And definitely, if more than 100 billion parameter, you need a multiple node. Multiple node is, each node is one system, and you can have multiple systems interconnected. And you can use a multi-mode node system. And if you want to do training of your own model right from scratch, let's say most of these models are English language-based models, and we might want to build an Indian-specific language model, then probably you need a data center scale compute requirements that can do this training of these things. Any questions so far? Okay. So continuing ahead, we'll briefly talk about Gaudi accelerators. So there are 3 or 4 different types of compute elements available in the market. One is the CPUs that I think everybody is aware of. And in the late 90s, a new class of requirement came, like there were a lot of video games, video editing, software animation, and things like that came up. And people thought they need a different type of compute element that can specifically target those kind of applications. That's when the GPUs came in. And GPUs were good at performing those kind of video editing, video games, and all those animation or graphics related things, GPUs were able to do efficiently. And after 2020, when ChatGPT and generative AI came in, there was a requirement that I want to do AI-related workloads more efficiently on that compute element. That's when the accelerators came in. And Gaudi is one of the accelerators from Intel that does only deep learning application. It doesn't do games, it doesn't do video editing or anything else. It does only deep learning. You can do a training of a deep learning model inferencing, fine-tuning, RAG. It doesn't do anything else. CPUs can do anything and everything. Gaudi GPUs can do 4 or 5 tasks more efficiently than CPUs. Accelerators can do only one job more efficiently. This accelerator is specifically meant for deep learning applications, right? And some hardware configuration. This is Gaudi 2 accelerators. One important thing that probably you might have to note is the 96 GB of onboard memory. Each card comes with 96 GB of high bandwidth memory. That means with one card itself, we can run a Llama 7 billion parameter model more efficiently than anything else. And it also has 24 integrated Ethernet, 100 Gbps Ethernet ports. Why is it important is, most of the time, generative AI models comes with multiple cards. If you are buying a Gaudi system, it comes with minimum of 8 cards. And all these 8 cards has to be interconnected. And if you see the competition generally uses a external link to interconnect their cards. But we have the standard Ethernet ports, which can be very easily interconnected. So you can interconnect the 8 cards within the system or multiple systems. So you can scale horizontally, or you can scale vertically, using these Ethernet ports without the need of any specialized linking technologies, right? So that way it is kind of reduces your overall cost of deployment. And from a software perspective for the Gaudi, definitely it works by default with PyTorch. So I think most of you will be using PyTorch if you're dealing with generative AI models for inferencing, training, or fine-tuning, any of these things. It works by default with PyTorch. DeepSpeed is one more open source framework that you might be using if you are dealing with generative AI. DeepSpeed is an open source framework specifically meant for dealing with multiple cards. If you have multiple cards or multiple systems and you want to deploy one model on that multiple system, DeepSpeed will make sure that all the multiple system behaves like a single system for the external model. Let's say you have a 500 billion parameter model, and definitely you will need multiple Gaudi systems for that, right? So you can use DeepSpeed framework, and DeepSpeed framework will make sure that the multiple systems, say, let's say you have 2 Gaudi systems with 8 cards each. So 8 cards with 96 GB of memory for each card, it comes to around 700 GB of memory for one system. So totally 2 cards will come to 1400 GB of memory. And now if you're loading a 500 billion parameter model, what will happen is the 500 billion parameter model will see that 1500 GB of memory and the 16 cards as a single compute element. It will not be shown as a total 16 different compute elements. It will be shown as a single compute element. Basically, DeepSpeed will internally manage all the parallelizing of the jobs and things like that. So it works by default with DeepSpeed. So other things, probably I'll not get into the, since there's a lack of time, I'll not get into the other things. Probably people who are more interested in to get into a deeper level, definitely there is access to deeper levels. And from the roadmap perspective, Gaudi 1 is available on AWS as DL1 instance, and you can also buy physical machines. Gaudi 2 is already available. It is available on Intel Tiber Developer Cloud, or you can buy the physical machine. And Gaudi 3 was launched yesterday. And so Gaudi 3 you can buy physical machines from the Gaudi 3. And next generation, we are definitely planning in the 2025. So this is a video, probably this is a video that shows how the silicon is manufactured. Probably I can skip it for now. There's a YouTube link. If you can go to the YouTube and search for Intel Fab, you will see this video. It's a pretty interesting video. It shows how the latest 7 nanometer or 5 nanometer silicon is manufactured. Basically, it uses this machine. This is a machine that is manufactured by ASML. ASML is the only company in the globe that manufactures this machine that can write that silicon circuits, write the circuits on those silicons. And it's a very technologically advanced machine. Like I said, only ASML manufactures that. Like if Intel, TSMC, Samsung, or anybody else wants to create their own chips, they have to use this ASML's machine for that. And for coming to where you can access resources for Gaudi, definitely on the GitHub, there are a lot of examples. There are a lot of optimized models, more than 40 plus optimized models. And Hugging Face, we definitely have more examples available. And there's also a GPU migration tool. So some of you might already have your generative AI applications deployed on, say, NVIDIA, and you have written your code in CUDA, right? You might have used CUDA library. So in that case, you can use this GPU migration tool, which will automatically migrate all your CUDA code to PyTorch Gaudi standard. Next, I'll briefly touch upon the Xeon processor, how Xeon 4th generation is different from the traditional CPUs, right? So Xeon 4th generation and above, currently we are on Xeon 6, just yesterday Xeon 6 was released officially. So now Xeon 4th generation and above, along with the normal traditional CPU cores, it also has separate silicon circuits called accelerators. So one of these accelerators that we are interested in is advanced matrix extension. That is a separate silicon dedicated circuit that is available on each of these Xeon 4th generation and above. And what this accelerators does is, it will fasten up all your computations, AI-related computations. So most of the AI computations, generative AI computations, involves matrix multiplication. And all this kind of matrix multiplication is enhanced by the accelerator. So instead of the matrix multiplication running traditionally on your CPU cores, it will run on the accelerators, and then you see boost in the speed of your inferencing or fine-tuning or training jobs that you will be running on your Xeons. And to use this accelerator, you need to do some small minor changes in your code. Let's say you already have a PyTorch code, and if you run your PyTorch code directly on the Xeon, it will use only the CPU cores. It will not use the AMX accelerator. Because AMS accelerator, the code, the object code that is required to generate is slightly different. So for that, what you need to do is, along with PyTorch, you need to patch it with Intel extension for PyTorch. What the Intel extension for PyTorch is just a 2-line code change. All you have to do is 2-line code change. What it does is, it will change your the final object code that is generated. It will change that to use the AMX accelerator for all the matrix multiplications. So that way, if earlier, if it was taking, let's say, 100 milliseconds, you might getting the inference time latency as 100 milliseconds. With 2 lines of code change, it might drop to 40 milliseconds. So you might gain up to 60 to 80% gain in the performance with just 2 lines of code change. And what this means, it means a huge amount of savings when you're actually talking about a huge scale. Let's say you're talking about serving 1 million customers. Then if you are having 60% reduction in the overall compute time, the overall compute required will be drastically reduced by 60% by that. So you and me as developers have the power to influence the overall production. So don't learn only the traditional way of programming. The traditional way of programming, use PyTorch and deploy it, that's fine. But then generative AI, like you know, this has huge cost, huge compute requirement. So try to optimize your code. All you have to do is 1 or 2 lines of code change you have to do, and then ensure that it works. You will gain around 60 to 80% gains in improvement. For the Xeon, we have optimized Intel, even though Intel is a hardware company, we also have a huge software engineering team working on the various open source frameworks and libraries that are shown here, like the Pandas, NumPy, PyTorch, TensorFlow, and other tools, to optimize those libraries and frameworks to work efficiently on the Intel hardware. And they are all also part of a standard called OneAPI. OneAPI is an open industry standard where multiple companies along with Intel have been trying to collaborate and create an open standard that can work across hardware. So if you are using, let's say if you are using CUDA can work only on NVIDIA, right? If you cannot run on GPUs, or it cannot run on computations GPUs, or it cannot run on CPUs. But if you are writing your code using OneAPI standards, using OneAPI standard compatible libraries and frameworks, your code is ensured to run on Intel's CPUs, GPUs, FPGAs, and as well as computations CPUs and GPUs. Right? It can run on AMD, it can run on NVIDIA as well. So you as an customer, you might have the independence to move your application to different platforms based on the need. You might be developing it on Intel, maybe you want to deploy it on NVIDIA, or you might be developing it on a laptop and then deploying it on a data center. So you have the independence to move across different hardware platforms. If you are using libraries and frameworks that are compatible with one API standards. Just to give you one example here, how many of you are using pandas or have used pandas, right? So traditionally you'll use pandas to read the CSV files or something like that. Here is an example where we are trying to read a 2.4 gigabyte CSV file using pandas, and it's running on a second generation Xeon. We are not even using the 6th generation. We are using a second generation Xeon CPU, and it almost takes 340 seconds to process that 2.4 gigabyte file. And what I did was, I used a optimized pandas framework called Modin from Intel, and the only change that I have to do is import modin.pandas.spd. Instead of writing it as import pandas.spd, I'll write import modin.pandas.spd. This is only one word change. The one word change that you as a developer do will result in almost 10x improvement. So instead of taking 340 seconds to read that CSV file, you'll end up taking only 31 seconds. Right? Your one word has so much of power to reduce the overall compute requirement, reduce the cost of deployment of an application. So try to learn optimization techniques as well. Right? An expert AI developer is one who also knows how to optimize their things. It's not only like anybody can now learn PyTorch and start doing an inferencing training and things like that. But you also need to know nitty-gritties. What is the underlying hardware? What is the underlying hardware capability? I will not blame you, because even before I joined Intel, probably I was also not aware of all these techniques. I was also a traditional programmer where I used to write all the traditional techniques that are available. But now, since I joined, I learned all these things. The modern day CPUs doesn't come only with this traditional core. It has a lot more features, and you as a developer might have to use those additional features to ensure that you gain those benefits. And for PyTorch, if you're using PyTorch, you need to write 2 lines of code change. You will be writing import torch and all these things. Along with that, write 2 lines of code change, like import Intel extension for PyTorch as IPEX, and then optimize your model with the IPEX. These are the only 2 lines of code change that you do. With these 2 lines of code change, if you're running it on Xeon 4 Gen and above, then suddenly you see that you're not only using your traditional CPU cores, you're also going to use the AMX accelerators. With the usage of AMX accelerators, suddenly you see 60 to 80% improvement in the overall inferencing or fine-tuning time. Xeon 4 Gen to 5th Gen, I think I'll skip. This is more of a marketing material, so I'll skip. Probably we are all engineering things. Let's not get into this marketing. It's mostly an improvement. There are a lot of improvements in the number of cores, a lot of improvements in the number of accelerators available, and memory and things like that. Now let's talk about AI PC. I think for people who have attended yesterday's session from Sriram and Anisha, probably this might be a repeat. So I'll briefly explain what is Core Ultra series approach. Like I said earlier, Core Ultra series is slightly different from your traditional Intel Core series processor. It is a single silicon with 3 different types of compute element, all burnt on a single silicon. Right? You have one processor that has a CPU, GPU, and a new class of compute element called neural processing unit. What the neural processing unit does is it can run efficiently all your AI computations with lower power consumption. Laptops are especially very concerned about the total battery consumption. If you're running your AI workload on a CPU, it might take, let's say if it is taking 10 watts of power for 5 seconds. And if it's a GPU, it might be taking, let's say it might be taking, I'm just giving a hypothetical number. I'm not exactly quoting the exact numbers. I'm giving a hypothetical number for reference, right? So GPU might take, let's say, some 8 watts or 7 watts. NPUs can still further reduce it by another few watts. It might come down to 50% of what a GPU might take. So that way you have 3 compute elements, and you as a user, if you are deploying an application, let's say you have an application that connects to a database, it connects to a REST API service, and then it also does an inferencing. So you can do all the inferencing on the NPU, and if you have a video rendering out the end, you might be doing a rendering of a video that you can do on a GPU, and you might be connecting to a database, read-write operations, and all those things that you can do on a CPU. That way, if your application is distributed to use these 3 different compute elements, you will see the amount of time it takes to process it will be drastically reduced, and you are efficiently using all the compute resource that is available on the Intel Core Ultra series. And here are some of the applications that are generally recommended or being built by our partners. Like you can have enhanced audio effects, you can have better gaming effects, or AI assistants can be built. We'll see how in one of our examples how you can actually run the Llama or the chatbot. You can have an LLM chatbot running on your AI PC. Here is, I think most of you who attended this session would have seen the difference. This is the frame rate difference, right? Like NPU gives you around 57 frames per second, CPU gives you around 28 frames per second, and GPU gives you around 280 frames per second. So NPU is kind of in between, in terms of performance, it is in between what a GPU offers and what a CPU offers. Also from the time, inference time it takes, NPU takes around 17 milliseconds. It's much better than what CPU takes, and definitely GPU has its own kind of performance. So this gives you an overall idea. So remember, when you're next, if you're upgrading your laptops, try to have a laptop or a desktop with Intel Core Ultra series of processor instead of Intel traditional. It might be slightly expensive, but it's all worth that additional money that you might be spending, because you're getting additional 3 different types of computing. You're not only getting the CPU cores, you're also getting GPU and NP, the new class of compute element called NPUs. This is not working. Okay. And to use all these frameworks, right, all these new type of compute element, we recommend using a framework from Intel called OpenVINO. OpenVINO stands for Open Visual Inference and Neural Network Optimization. It's an open source framework from Intel where you can use this to do your training, fine tuning and inferencing of different models, different AI models, both the traditional classical AI ML as well as the generative AI models. Yeah, OpenVINO can work with PyTorch, TensorFlow, Keras, and other things, and it works across different types of hardware, right from Atom, Intel Core series, Intel Xeon, Intel Core Ultra, from the GPU, all the different types of GPUs, as well as the NPU and FPGA. FPGA is a different class of compute element. How many of you are aware of what is FPGA? 1 or 2 hands. So FPGA is traditionally it's a new kind of a silicon. It's a different type of a silicon where you as an end developer, end user, can create the circuits. So CPUs, the circuits inside the CPUs are pre-built. The manufacturer will write that circuits and you cannot change it. It's all fixed. With the FPGA stands for Field Programmable Gate Arrays. That means you, at the end user, can actually create the circuits. Whatever circuits you want, you can write that circuit on that silicon and then use it for your application. Let's say you are in the automobile sector and you might want a customized CPU for your automobiles, this thing, right? You might have some custom application. So you can create your own customized application using FPGAs. So Intel has an FPGA that some of the mostly enterprise, some niche segments users like healthcare, automotive and other things, they use our manufacturing where you want to deploy some specific use case. You can use FPGA. Yeah, these are traditional benefits. Probably I'll quickly, I think we are running out of time for the workshop, so I'll quickly skip through these things. There are notebooks available. Probably in this today's this thing, we'll go through the very first example that we'll go through is the post estimation. We'll see how to run this post estimation on your laptop and see how it is, how you can run this on your laptop. And then we'll try to, if time permits, we'll try to do an LLM chatbot. So let's get into the action. We'll get into the first one. Probably let's do an post estimation, the easiest one. I think it's already loaded onto your laptop. Probably have the Jupyter notebooks in front of you with post estimation as the thing. How many of you are aware of what is Jupyter notebook or Jupyter notebook? Okay, so for those of you who are not aware, I think majority already knows. So Jupyter Notebook is a web interface to execute your Python code, right? You can run easily all your Python code. So we have already pre-installed all the Jupyter Notebooks, dependencies, OpenVINO frameworks, everything on your laptop. and all you have to do is just execute certain things. Can I switch to my laptop? Yeah, thank you. So remember, this is a live demo that's happening, and some things can go wrong for few of us. So don't worry, we have our engineers here. They'll be able to help you out. I think I have my Jupyter lab running. Just give me a moment. Let me restart my Jupyter notebook. So we use the pip installer. Pip is again a package manager for Python. We use that to install the Jupyter notebook. So once you install the Jupyter notebook, you might see an interface something like this. I think most of you have the workshops loaded. So in this workshop, I wanted to do the post estimation. So what I'll do is, since we are dealing with Windows, one of the issues that I've seen with Windows is the permission issue. If I copy a file from some other system via USB pen drive or something, and if I try to execute, it gives you generally permission errors. Generally, to avoid permission error, what I try to do is I'll try to duplicate that. Duplicate the notebook. I duplicated the notebook. Let me duplicate it. So if I duplicate it, magically all the permission error vanishes. These are all some of the nitty-gritties you might learn as part of your journey as a developer when you're dealing with all these things. Okay. So I think everybody has this screen. Anybody has trouble seeing this screen on your laptops, on your local laptops? Can anyone help? So Sanjay, I think there's a person who has issues. Yeah. Anybody else has issues seeing this Jupyter notebook, this particular notebook launched? So while Sanjay helps one of the participants, I'll briefly explain, right? So on your left, you will see all the files and folders from that are available. On the right, you have the interface to show the contents of a particular file that you have opened. One of the important things is probably you need to know this is the run button. You run these cells, basically you are executing the cells or the code that is available in the cell. And other important thing is the kernel. By default, we are going to use the Python kernel. There's no other kernel. If you are using, let's say if you are using GPUs or like data center GPUs or things like that, you might install your own custom kernel. For now, we will use this Python kernel, ensure that Python kernel is selected. Mostly it will be selected on your laptops. If not, just go and change it to Python 3. And for now, what we'll do is we'll run this code. Don't change anything in your code, right? All you have to do is simply click the few buttons. There's a very good documentation on that is available. Each of the code is also extensively documented so that you can easily learn what exactly is happening. It's also open source. If you want to access this later on, right after you leave this workshop and still want to access these notebooks, all you can do is OpenVINO notebooks. Search for OpenVINO notebooks. One of the first links that comes up is the GitHub link, which has all the open source notebooks. The notebooks are available here in this notebooks directory. We'll be running only 2 examples here, but there are tons of other different types of examples, including a lot of LLM related models, like how to run a Lava model, LLM agent, LLM chatbot, LLM question answering, LLM RAG implementation with Llama index and things like that. I think you might be finding it.
GitHub pages, if you show that the GitHub pages.
GitHub page?
Yeah, just click on that.
Yeah.
Scroll down. There's a GitHub pages.
Yeah.
So this has.
Yeah, so this has all these things here, so please use it. later on, like once you go back, you can definitely use all these notebooks and try run. Some of these notebooks you can run on your traditional core also. If you have a traditional Intel Core series of laptop or even an AMD laptop or anything, you can still run it on that or a desktop, right? You can run all these things. Ensure you install the OpenVINO framework before you run off any of these notebooks. So let's start executing with the very first cell. The cell that is highlighted by blue is the very first cell. It contains some documentation saying that this is a human pose estimation. We are using a model called human pose estimation. This is the model that we are going to use from Open Model Zoo. Model Zoo is again a list of open source optimized models from Intel. You can go there and you can download a lot of models that are for different types of use cases available. And before we begin, probably we might have to install OpenVINO and other things. So I think most of your laptops already has this thing. But anyhow, go ahead and execute that. When you are executing it, you'll see a star icon, and you'll also see a time icon here on the tab. That means the code is being executed. So when you install any libraries or frameworks on your Jupyter Notebook, generally it is recommended to restart the kernel. It will give you a notice saying that you might have to restart the kernel. So restarting the kernel is go to the kernel menu and say restart. Okay, I restarted the kernel. I'll go to the next cell. Now I'll go and import certain things. It's getting, I think it already executed that. Now I'll go ahead and download the model. I'm downloading the model, human pose estimation model, and using mixed precision, both FP16 as well as int8 precision I'm using. I'm downloading to a particular path. So once it is downloaded, I will try to load the model. So before we load the model, you will see the options, right? What are the different types of compute element? For now, keep it as auto. We'll go with auto, but later on you will try it with CPU, GPUs, and NPU, right? So the code has detected that your system has 3 different types of compute element. If you are running it on a traditional Intel Core series, you might only see CPU. Along with that CPU, if you have inbuilt graphics card, it might show the GPU. You might not get the NPU options. Next, I'm compiling that code with the OpenVINO runtime. So you take a model and you'll then compile that with the OpenVINO runtime. And then we are doing an open pose decoder. Basically, we are transforming the raw results from the neural network into pose estimations, right? Using that model, human pose estimation model. So basically, this particular model has a lot of extensive usage in enterprise use case as well, right? There are applications being built for crowd management. If you want to do a crowd management kind of an application, you can use this model where you can actually see how the crowd's behavior is. Is there any violent behavior happening within the crowd, or if somebody is immobile for a longer period of time, you might want to alert or things like that. So you can do a crowd management kind of an application using this model. It's a very small model. It works very efficiently on your laptop itself. Let's execute all this code for now and see the results first. We are also trying to color those lines. Once you detect all the pose estimations, we'll use different coloring lines to do that. And now we will run that and we'll draw that. I'm using the webcam is equal to true. If you set the use webcam is equal to false, it will use the sample MP4 file. Otherwise, you can use your traditional. If you are not comfortable using your webcam, you can use the sample file. For this demo, I'm going to use the webcam. So once I run the webcam, I can see my estimation. So it can detect if I show my full body, it will basically detect my complete body. It can detect how my hands are moving, how my eyes are moving, things like that. And with this thing, right, each of the body parts is labeled with different types of colored thing, so you can specifically identify which body part is moving, right? Say for example, you can also use this human pose estimation in automobile sector, right? You can have a camera that is seeing the driver, and the driver is not moving his eyes, or if he's lousy, you can detect using this kind of models, apart from cloud management. So it's currently, I think it's running on, looks like it's running on CPU. Let's try to change the, how many of you have struggle arriving at the final result? Everybody at the final result? You have problems, or you are able to, you are at the final results? Okay, good. Now let's play around with it, and let's see how it behaves differently. Scroll up to your code and change the device type to, let's say, NPU or GPU, whatever you want. Just play around with it. I'll select NPU, and then I'll run the code. Probably I need to stop the execution of the earlier one, otherwise it might not free up the resource. Yes, I'll stop it, I'll go back, I'll select the NPU. Huh? Let's see how the frame rates are with NPU. I think the frame rates are slightly reduced. It came to around, I think earlier it was running with GPU, now it has slightly reduced, but the inference time is pretty good. So you try it out. Once you are done trying it out, let me know. Then probably we can switch over to the LLM chatbot. Anybody facing difficulties in trying it out? Let's switch between different compute elements.
Upgrade this version. So I tried to upgrade it.
Why did it ask? It should not generally ask.
So
It's
it
okay.
asked me.
Okay, fine.
So now I installed it, but when I run it again, it is not happening.
Laptops, even if it doesn't have the Core Ultra, you will still be able to run it. So the next example that we are going to try, anybody wants me to wait for a few more time? Anybody wants me to wait? If you want me to wait, please raise your hands, otherwise I'll move to the next. I think we are good to move to the next demo. So the next demo is a chatbot, LLM generative AI chatbot. Let's see, we have options to use various types of model. We'll use one of the smallest model in the interest of time. Because if you use a larger, we can run 7 billion parameter or 8 billion parameter model. You see in the list of models in the example, a lot of different models. Maybe once you go home, you can try out the different larger models. But for this particular workshop, we will use a smaller model. So what I'm doing is, I'm going to have the chatbot. I'll duplicate, just to be on a safer side, I'll duplicate this notebook. I'll stop my previous thing. Probably I can shut down, I can restart the kernel. So let me restart. Let me ensure that you have stopped the post estimation before you switch to the new one, so that your compute resource is freed up. This LLM chatbot will require a little bit more compute power than the human post estimation. And this might most likely will be running only on your Core Ultra series of process. This is because LLMs are generally compute hungry applications. You might need a little bit more powerful compute elements. So I'll run it. I'll show show you the demo, and then probably we can talk about the nitty-gritties of that. I have installed all the packages. It's asking me to, let's wait. It's installing all the packages. You see this time icon here. That means it's executing. It's still installing all the packages. Most of you it might already been installed, but you can still run through that sample. So here I'm installing IP widgets, Optimum and Optimum Intel. These are all frameworks that are specifically meant to enhance the performance on Intel hardware. And we are also installing OpenVINO. I think OpenVINO was previously installed in the previous example, so you don't need. And then we are also installing PyTorch that can run efficiently on the CPU. So this pip install is basically installing the PyTorch on the CPU version of the PyTorch. And all the other dependencies like accelerate, Gradio is basically used to build user interfaces. If you want to build some simple HTML user, not simple, even you can build a very complex HTML interfaces with Gradio. And then we are also using transformers and things like that that will be used for basically doing the inferencing of this. I think it has run successfully. I'll restart my kernel. So once I restart the kernel, I'll manually select the next cell. I'll download certain utility files and things like that. I think this must be already there on your laptops. So I'm selecting what type of models I want. By default English is selected. I think most of you will know only English. I am not sure if anybody with Chinese or Japanese languages here. I'm assuming they are not here, so I'll switch to English directly. And here in the drop down you get to see different all these models. You can run it right on your laptop, right? So here we have I'll be using by default the 500 million parameter model. It's a 500 million parameter model. I'll not use a bigger model for this example, but you can still go ahead and try a Llama 2 7 billion or a Llama 3 8 billion parameter model running right on your laptop. So this can actually break the myth that you need GPUs, powerful GPUs to run all these huge generative AI models. So I'll leave it to the default model that is selected. All these are open source models. I have selected the model, the very first one, and then I'll load. I'm using the quantization. There are different types of quantizations available. I'll leave it to prepare. I'm actually since I'm running it on a laptop and I want faster speed. In this particular workshop, I'm not much concerned about the accuracy to a great extent. I mean, if you are compressing your model from say FP32 to int4 or int8, and there's a very slight degradation in the accuracy, but that is acceptable for most of the applications. For some sensitive applications, you might need higher degree of accuracy. Then you can ensure that you can use FP16 or FP32 as well. But then you'll have a trade-off on the computing requirement. Your inferencing time might increase slightly based on the data type that you might be using. There's also something called activation-aware weight quantization. It's an algorithm that tunes model weights for more accurate int4 compression. Currently, we will not enable it for now because it usually takes some time to prepare your model with that this thing. Probably you can try it out later. If you do this, your model's performance will slightly increase further. It's a one-time job that you might have to do, but then the inferencing, multiple times of inferencing will, the performance increases drastically. Again, you will get the list of devices where you want to run. I think NPU is removed. I think they have written a code to remove the NPU for now. But yeah, we will leave it as is and run it. I'm using the int4 quantization. Yeah, so once you come to the final one, you should see an user interface. Let's wait for it to finish executing. You'll see a simple user chatbot, ChatGPT kind of an interface running right locally on your laptop. And all the queries that you do to this particular thing will be running only on your laptop. Nothing, no data leaves outside your laptop. I think this will take some time because it's actually quantizing that model and changing things like that. So I think finished execution. Is there an error occurred? Let me see if there was an error in one of my previous steps. Yes, looks like there is an error in one of my previous steps. Some module. Anybody facing this error? How many of you are facing this error?
Not exactly same, but a different error.
But it's still a module not found error. So probably I think we need to execute the very first line. Yesterday night it was working fine. Like I said, it's all live demo. Some things can go wrong, and all these laptops have been circulating to various workshops, and a lot of people have meddled with these laptops, and things can go wrong slightly. So let me rerun the things again. Probably I'll restart the kernel. We have sufficient time, so let's experiment. I think these are all some of the challenges that we face day in, day out. As an engineers, we keep encountering errors. Things that were working 1 minute ago will start failing when you actually do the demo. So that's fine. We'll fix it. Let's wait for the packages to install. Is there any permission? Just look for if you get any error. Is there any permission issues that are coming up? If you get a permission issue, most likely you might have to make a duplicate of the notebook and try to run the duplicate one. It's taking some time to install the packages. I'll wait for the packages to finish installing. How many of you are able to successfully run? Oh, very good. At least we have a couple of hands. Can you experiment, try to experiment, ask the questions that you generally ask to ChatGPT and you can get the answers for that? Good, we have a couple of hands. What are the other challenges? Most of you are facing still that module not found error? Okay. I think we have very few lucky people, some 3-4 lucky people here getting it running for the way, on the very first run. It's taking unusually long time. I'll try to restart the kernel. I don't know what's happening. Let me try to install the missing modules. Probably what you can do is you can go to the file terminal and then do a pip install. Pip install the module name. Right. What you can do if you are facing module not found error, go to file new terminal, file new terminal, open a new terminal and then type the missing modules, install it via pip install the missing module. It was working all fine yesterday, but yeah, today something. Today it's probably not happy with me. Anybody got success fixing that module not found errors? How many of you are able to get it successfully running now?
It's going on. It's downloading the model
Ah.
and quantizing it. It
Ah.
will take time.
It will take time, yes. Let's wait for that to finish installing maybe the internet. Let me check if my internet is good. Maybe we are all connected to the same network. The internet is slightly slow. And that's why it takes time to load the packages. Anyway, we have still 45 minutes. Meanwhile, if you have any questions on things that we discussed so far, we can ask. I think it installed now. Error, subprocess exited. Let me restart my Jupyter kernel, Jupyter notebook. Let me switch the network. I think the network that I'm using is pretty slow. Thanks, Pawan, for helping me with the network. Okay. Hopefully this network should be better than the previous one. Yes. So let me try it out now. There's some warning for me that Optimum was not installed. Probably I'll try to reinstall that. Please read the error message carefully. Probably the answers might be there in the error message itself. Additional CPUs as well. It might be slightly slower, but it's okay. I think at least you can run it and you can see, you can break the myth that you need powerful GPUs to run an LLM model, right? You can still run fairly decently, and it's the time it takes to give this answer is fairly decent enough. It's not taking too much time. It's almost taking similar time to as ChatGPT, but we cannot compare to ChatGPT. ChatGPT is a 1 trillion parameter model, and this is just a 0.5 billion model, right? Like it can, like I was discussing there, like it can hallucinate. Like I can ask, who is the current Chief Minister of Karnataka? I didn't even spell Karnataka correctly. Let's see what it gives. We can push it. Okay, for me it's giving kind of an better answer than what the user there here. For him it gave the answer as Biren Singh. For me it at least gave B.S. Yediyurappa as the correct answer. So what I was trying to show is sometimes these LLM models has a tendency for hallucination. Even though if it doesn't know the answer, it will try to give some answer, try to cook up some answer for you. So in an enterprise use case, you should be aware of that hallucination problem and try to build guardrails before you send the output to the end user. Ensure you build the guardrails and filter down, ensure the answer that is coming out is accurate. Now I would like to show other demos. Probably you can play around with it later on. I'll show some other quick demos. One is it's a model that can generate a music for you. How many of you are using the open source tool called Audacity, AUDA? Let me type it. So Audacity is an open source tool for all your audio editing applications. Like if you want to cut, copy, paste, generate, say you want to add effects to your audio and all things like that, you can use this tool called Audacity. And we have Intel has developed a plugin for this. It's called an OpenVINO Audacity plugin. You can go to Google, say open. Probably most of your laptops will not have Audacity, so you will not be able to try it out. If you want, you can try to install Audacity and try it out later. What you can do is OpenVINO Audacity plugin. There's a plugin for Audacity, and what I have already installed that plugin. What I'll do is so once you install the OpenVINO Audacity plugin, right, in the generate option, there's a separate new menu that comes up. It's called OpenVINO Music Generation. Now everybody can become a musician, right? They can actually create music. So I'm using a model called Music Gen Small FP16 Stereo. This is the model that I'm using. Let's say I'll give the prompt as 80s pop track with bassy drums and synth. And I can select where I want to run the codec. I'll leave it for default now. Seed is something, if you want the same music to be generated for the same prompt always, use a constant seed, or leave it blank so that a random seed is generated, so a random music will be generated every time you give the generate button. So I'll click on the generate. So now this model is running right on your laptop to generate a music. What you saw earlier was you gave a text prompt, you got a text output. Now this one is you gave a text prompt, you are getting a music as the output. So if you want, if you are having any of your functions or any YouTube videos that you are creating, instead of downloading some open source or copyrighted music materials, you can create write a prompt and generate original music for yourself. And this is again the challenge for all the creative industry, right? Creative industry includes you and me, where we are writing code, or the film industry where they're generating music, they're creating films, things like all this creative industry, skilled workers are being challenged by this generative AI. There are models that can write code, so that means the models can be a challenge to you and me. And then there are models that can generate music, so that means it's a challenge for ARM and all the musicians in the world. So probably 5 or 10 years down the line, what you can see is an LLM model can write the entire script for a movie. And models like this can generate a song, it can write a lyrics for that movie, for a particular song. It can generate the music. And then there are models which can actually sing in a particular voice. So I can take popular singer's voice, and I can train that model. And then I'll give the lyrics as the input. And it can sing that particular lyrics in that particular singer's voice. And then you can combine it with this music. And then there are models which can generate entire video. If you there's a model from Google. I don't think there's any open source model. Currently, there are proprietary models. There's a model from Google called Imagen. And this model, you give a text prompt, and it can generate a video for you. So technically, 5 or 10 years down the line, once the compute element is like, once we have access to all those heavy compute elements, you can create the entire movies through generative AI models. You don't need real world actors. You can have real world looking actors generated by AI performing all the actions. The script is generated by AI, the music is generated by AI, the lyrics is generated by AI, and finally even the rendering of that entire movie is generated by AI. So seems to be an exciting, can be taken in two ways. It can be an exciting world ahead, or it can be a challenging world ahead. It depends on how we take it. It's for me, this looks like an analogy like in the early 90s, right? When computers were being introduced, and there were a lot of protests, especially in India, and there were a lot of protests that were happening. that computers can take away jobs, especially in the banks and things like that. They were protesting that computers can come up. So this is. So these are the, I think, images. There's also one video, image and video. Let me see if I can show you that video. Yeah. So this is the image and video is a model from Google Research Labs. It's not an open source model. It's currently a proprietary model for Google. So all this video that you see on the screen is all generated by, for example, this pandas. A panda bear driving a car. You give this prompt and the video is generated. Currently, these models are able to generate a few seconds of video, but definitely as the technology progresses, entire movies probably will be created with the models, right? A tiny plant sprout coming out of the ground. So this looks so realistic, right? It looks like a real time-lapsed video that is coming up here. Right? This is a time-lapse video showing, but it's actually a completely AI-generated video. And all this that you see is all AI-generated. So you can imagine an exciting world. At least we are lucky that we are able to see this transition from heavily manual work to completely automated work that's happening. Probably the future generations will be more used to all this automated thing. They'll not be able to appreciate how much work was involved in getting to the stage where we are in. Hopefully the music is, yes, the music is generated. Probably let me play it. Let me see if my audio is all correct. Audio. Connected, yeah. Speaker source. Output device, yeah, output device equal this one. Can you hear this music? It's being generated. So this is the music that was generated from the prompt that I gave, and it's a free open source. These are all free for you. Imagine the free things can do so many things. What proprietary things, what customized things can do, right? And all this is running right on your laptop. This is a simple, hardly some 50 or 80,000 rupees laptop can do so many creative things. It can be so much of challenges for you and me. This is one thing. One other interesting thing that I would like to show you is where it can be both a challenge or both an helping assistant for us. We also have a plugin called OpenVINO Visual Code plugin. So you can search OpenVINO Visual Code plugin. So before I show this plugin, there's a survey form that I want everybody to fill up. Sriram, are you there, Sriram? Can you talk about the survey form?
Ladies and gentlemen, you would see a QR code scanner on your desk. Please use that because Intel has some amazing little surprise for you. And for people who do not have access to QR codes there, you can also scan the QR code from here, which is on the desk.
Please scan the QR code. Please provide us your feedback.
Also, once you have scanned the QR code, you will get multiple options. You would have to select the last option. Just let me give you. Thank you. So this is the QR code.
So coming back again to the final demo that we have here, that's going to be useful for you and me. What we have here is a code completion tool, a plugin for Visual Studio. It's available freely on the Visual Studio Marketplace. Just go to Google and search OpenVINO Visual Code plugin. You'll get one of the first links, that's this one. Click on that. You can install this plugin. So just a few clicks, you can install it. If you have the Visual Code, just go ahead and install this. Once you install this plugin, you can open your Visual Code, and you will see this new icon here. The new icon at the bottom. There's a new icon here called OpenVINO Code. Once you install the plugin successfully, you should restart your Visual Code, and you should see this plugin, this new option here. What this new option gives you is it can run code generation models right on your laptop. So there are also proprietary tools like, say, Copilot and others which can give you these services where you enter a prompt. Let's say you enter a prompt to write a quicksort algorithm, and the prompt will go to an external service and you'll get back the answers. Here, all the things are happening right on your laptop. Nothing leaves your laptop. So there are multiple models available here. I'll use one of the default model, and I'll click on the start server. It takes few seconds for the server to start up. The server is starting up right on your laptop. I personally feel all these models might be pretty useful for us, especially in fastening up our development time, right? So earlier, if you have to write something, if it was taking 1 week for you to write, now you can write it in, ask the model to write it in 1 or 2 minutes, and then spend some 2-3 hours to review the code, and in a day your job is done. So that will basically reduce the overall cost of software development, and probably that will enable access to the software, access to the technology to an even more wider audience, right? Just like the banking example that I was talking earlier. So initially there was a lot of protest in the 90s that you should not introduce computers to the banks because it will take away the jobs. But now if you, after 20, 30 years, if you look back, what's happened, actually happened is computers has brought down the total cost of banking operations so low that now we have banks in almost every street. In every street you might find 2-3 banks. Earlier, maybe in entire Bangalore there might be some 10 banks, and you need to have a lot of recommendations, things like it's like owning a bank account was a great thing. But now anybody can open an account. It's so fast and so easy to open an account. And there are so many banks in each and every street, so many ATMs are. All this is possible because computers came in. They brought down the cost, and now if you see the total number of employment, earlier if let's say if only 10,000 people were employed in the bank in the 90s, now there are more than at least maybe some 2-3 lakh people in the banking industry, right? So basically computers has enabled more people to be hired into the industry, and it has brought down the cost of the service. So similar things might happen here. The entire cost of production of creative things can come down. And for all that to happen, you as an engineer or you as a skilled people should be always ahead of these models, right? You need to know how these models internally work so that you can get better outputs out of these models, right? That way, you will be more relevant in the industry. You need to be upskilling yourself. The challenges are coming up very fast. You might be thinking this is just a sample POC that we are showing up here. Already many of my customers are already working on extensive enterprise grade code completion tools, and definitely 1 or 2 years down the line, almost all the companies will have some kind of code completion tools, and that will significantly reduce the overall manpower requirement for a particular job, but might open up many other types of jobs, right? So that way, it's a challenge that's coming up. So be prepared, keep upskilling. It's good that you have come up, you are spending your precious 2-3 hours on this working day here to learn something new. That will definitely be beneficial in your journey ahead. So now coming back to the demo, I installed I think the server is now up and running. I have trying to write a code for quicksort. All I writing here is just the definition. Like I'm writing only the title, like definition quicksort. This is a Python code that I want to generate, and I'll write this, and I'll go ahead and click on generate code completion. Now it's going and generating me the quicksort algorithm, including the comments and things like that. This is a very simple example that I'm trying to showcase here, but definitely it can do a lot more complex things, and there are different models for different languages. For Java, there's a model. For SQL, SQL is something that's kind of a nightmare for at least me, and I think many of you still have writing SQL join statements. If you are given a complex SQL join statements, probably you'll be having nightmares. All those nightmares will be removed by this. Instead of you taking 3-4 days to optimize your SQL statement, put a prompt, get the answer in 5 seconds, optimize it with 30 minutes, and your job is done. And your code will be more better than what a 20 years or 30 years experienced guy, probably even the SQL inventor probably will not be able to write the kind of code that this will be generating. So that's actually a boon. I think it's finished writing the code. So that's what the example is here. So I'll recommend, this is a tool that is for Visual Studio, but if you are using, let's say if you are using a Mac, or if you are using any other tools like Eclipse or things like that, you can easily build an plugins for this kind of things, right? If you're, I want everyone to be lazy. I don't want everyone to be like very hardworking writing all the code. When you have this kind of super agents working for you, why do you want to be hardworking? Spend 1 or 2 days to write a plugin for your IDE, and then use these tools. Your manager comes and gives you, or asks you to write something, right? Write an algorithm, put a prompt, and take. He might be giving you 1 week of time to write. You spend 1 hour, and next 5 or 6 days you spend happily watching movies or doing something more creative, right? Be lazy. Don't be very hardworking, or do smart working rather than being lazy or maybe smart working, right? Use the smart tools that are available for you. Not only for this, right? All this, I think most of you want to, at some point in time, might want to wish your friend to write birthdays or something. Like, instead of writing a message, maybe you can use tools to create a customized birthday greeting cards and feel people more important to you, right? That way you are personalizing. And the effort that you are spending is like 5 seconds. With 5 seconds of your effort and the message that you convey to your customers, to your friends, to your knowns will be more close, it will be more important messages. Yeah. So I'm open to more questions. So remember, this is just the beginning of our engagement. My engineering team's sole responsibility is to make sure your enterprise, if you're working on any enterprise use cases, we are there to help you. We give you free consulting in terms of choosing the right hardware and software stack for your AI applications. At any point in time, if you have any AI applications that you want to run, do contact us. I'm available on LinkedIn. If you can search on LinkedIn Anish and Intel, you probably will get my name there. Let's get connected, and if you want, we can have an initial meeting to discover what's the problem that you have. Probably we can give you access to the latest Intel hardware as well, like the Xeons or the Gaudi accelerators, based on the use case that you have. And then my engineering team will closely collaborate with your engineering team to help you optimize your code and get the best results out of it. Since we are dealing with so many customers across this Asia Pacific region, we have a very wide range of data set, wide range of options available, and we can give you the best so that you don't have to, you can focus on your key problem rather than focusing on the generic things that are very common to across all the different customers. So I think with that, we are open to questions. We still have 8 minutes, so we can open up for questions in your. Can we connect the slides back? I think we already showed the bonus Audacity music generator. We also showed you the Visual Studio code generator. Here are some of the important links. Probably I want everyone to just take a snap of this one. The very first one is in the OpenVINO that we discussed now, and the second one is on the Gaudi AI Accelerator. There's also tutorials and Hugging Face models that are available, so please use that. And remember, we are also available even after this workshop at any time. Do feel free to contact us, and we will help you in your AI journey. Done. So here's my LinkedIn, and we are open for questions. There's my QR code for my LinkedIn. We can get connected there. Feel free to contact me anytime, and I'll arrange my engineering. There's a question there. Can you please pass on the mic?
Hi, can you hear me? Yes.
Yeah.
I'm Saket. I write software. So basically, is there any way to run a proprietary model locally without, giving up the weights, but still generating things locally? Like you had Intel SGX earlier, like secure enclave, that's what, say, OpenVINO or other decryptors use. Is there something similar for LLMs that you foresee?
So your question is, can I run a proprietary model on the local laptops or on your own private machines, right?
Yes.
So I mean, as the name implies proprietary, that means somebody is already owning it and they are not open, they are not willing to give you access to that executable code, right? So that means the answer is kind of no, unless you want to hack into their system and download their IP. So probably it's no, and it's not required. I mean, you don't even have to do that. I mean, currently there are so many options, open source options available. You don't even have to look at the way that you need only proprietary models to do your job. For all the proprietary models that are available, there is an equivalent open source, equivalent or sometimes better open source models available, right? So mostly these proprietary models are good for non-technical people, right? For people who are non-technical and they want to use ChatGPT or other things, that's good. Like I think Mid-Journey, other things, if you want to use other proprietary tools, it's good for them. For you and me, I think we should start using the open source models, and definitely you can fine tune and do a RAG, like you have a lot of huge amount of historical data, do the fine tuning, and you need to have real-time data, do the RAG, and then definitely do that. And run it on your laptop or data center scale machines.
Sure, makes sense. Thanks.
Thank you. Any other questions? We have 5 more minutes. If anybody wants to discuss any specific use case that you are working on, if you want any specific suggestions, we can discuss that. Otherwise, I think we can wrap it up for today. Thanks for being a nice audience. Thanks for coming early and going through we had some small technical glitches, but that's part of our technical journey. They are definitely, we are all as an engineers should fix those small nitty-gritty problems that might come up. And thank you. Thanks.